Equipartitioning, again, this thing that's just sitting around. See, this is a subtle point. I'm just going to throw it in here, right? So we've gotten to these power law size distributions, and I just want to go back and mention this because this is part of it. So now we've got a to the minus tau. So think of this as counting, right? This is a number thing, we're counting. So if we multiply area times the probability, then this story suggests that we should get a constant, right? Because the number of basins of a particular area times their area seems to be roughly constant. But that's actually not true, right? When we look at the power law thing, because this is a to the minus tau plus 1. And this is usually around, well, say for, for Scheidegger, for example, this is 4/3. So this is actually a to the minus 1/3. It's usually greater than 3/2. Smaller than 3/2, yeah. So what's going on here? Like, why is this decaying? And it's because when you look at it in this way, you're overcounting things because there are basins within basins, right? Because now you're also thinking about, it's more of a continuum story, and all of these, there's this basin, and then this basin, and then this basin, right? So if we, in this little dx in here, you've got all these basins, as we sort of go along here, they all have the same area, basically, right? They're all being counted. So they're not, so what you have to do is kind of say, well, this is not these are not separate basins, right? We're partitioning this landscape, but when you do this calculation, you're actually counting all these basins that contain each other. So you get this, so things don't work. You don't see it from this point of view. You don't see this equipartitioning, all right? Because you have to enforce this thing. Say, I really don't want to count this one, but because you're now sort of looking at a continuum thing, you tend to count too many. Okay, that's where that should have been.